Question 12a. If S is equal to, you have a column vector or column matrix with element 2, 3, y equal to 5 minus 2, z equal to minus 4, 13. Find the scalars P and Q such that PS plus QY equal to Z. So this is the equation. You simply replace S, Y, and Z with the column vectors in this form. When you multiply, you get this. When you add the left hand side, you have 2P plus 5Q in this form. 3P plus minus 2Q. You have 3P minus 2Q equal to the right hand side. By equality of matrices, the first entry here equal to the first entry, second entry equal second entry, and you have a system of linear simultaneous equation. So we solve them using elimination method. You have the two equations. Now we want to eliminate variable Q. To do that, Q must have the same coefficient in both equations. There is 5 and 2 already. The LCM is 10. We have to make 5 to be 10. To achieve that, multiply through equation 1 by 2, and to make 2 to be 10, you multiply through equation 2 by 5. So you have 4P plus 10Q equal to minus 8, and you have 15P minus 10Q equal to 65. We are adding because the signs for the coefficients are opposite in both equations. When you add, Q disappears, and you have 4P plus 15P, that is 19P equal to minus 8 plus 65, you have 57. Divide through by 19, P is equal to 3. To get Q, we simply replace P with 3 in equation 1. You can also use equation 2. Equation 1 is this. Where you see P, you replace P with 3. So you have 2 times 3 plus 4Q equal to minus 4. Minus 4. Now this is P equal to minus 4. If you transfer 2 times 3, that is 6, it becomes minus 6. So 5Q is equal to minus 10. Divide through by 5, Q is equal to minus 2. Therefore, P is equal to 3 and Q is equal to minus 2. Question 12b, Roman figure 1. Using a scale of 2 cm to 2 units on both axes, draw OS and OY for minus 5 less than equal to S less than equal to 5, minus 5 less than Y less than 5 respectively. 2. The quadrilateral WSYZ with W, this coordinate, you have S, you have Y, and Z. Roman figure 3. The image WSYZ of the quadrilateral WSYZ under the anticlockwise rotation of 90 degrees about the origin, where you have W, W1, S, S1, Y, Y1, and Z, Z1. Solution to this question. So you have the two axes, OS and OY, and the scale is clearly stated 2 cm to 2 units on both axes. So the first point here, that is when S is 2, y is 3. This is point for w. This is the point for s. When s is 4, y is minus 1. Then y minus 3 minus 4, and z minus 3 for s and 2 for y. So we have to get the quadrilateral by joining the points together. So from B, Roman figure 2, you've joined all the points together and you have the quadrilateral. Then Roman figure 3, you are to form the image. You also plug, but remember the rotation is anti-clockwise, so we simply interchange the position of 2 3 to minus 3 2 because of the anti-clockwise rotation. Then 4, what is affected is the second point. 4 minus 1 becomes 1 and 4. Minus 3 minus 4 becomes 4 and minus 3. Then minus 3 2 for z becomes minus 2 minus 3. So you plot the image as well. So you have w1, you have z1 is there, you have y1, and you have s1. Next, you join them together as well. The points from the image have been joined together and you have the complete solution to that question. The quadrilateral WSYZ and the image W1, S1, Y1 and Z1.